An annual sports festival is held over a period of 11 days. A tuck shop sells hot drinks at this festival. On each of the first 10 days, the owner of the tuck shop recorded the temperature at 1 p.m. and the number of cups of hot drinks sold. This information is presented in the table and scatter plot below. We have the temperature for the 10 days from 14, 24, 26, so on until 19 on the last day. And then the number of hot drinks 410, 258 to 280 on the last day. And then we have our scatter plot. And then 1.1 says describe the data. So let's look at our scatter plot. On the x-axis, we have the temperature. And then on the y-axis, we have the number of hot drinks sold. Right? Now, let's look at our data. Let's ignore this point here because it's very far away from all the other points. Let's stick to these points that are on a linear, so to say. So, there we go. Yeah, we have something like that, right? So it's easy to see now that when the temperature increases, the number of hot drinks sold is going down, right? Apart from this point, which is a bit deviating, and this one, which is totally an outlier. But then the general trend, when the temperature is increasing, the number of hot drinks sold is decreasing, which makes perfect sense. You would expect people to buy less hot drinks when the temperature is increasing, right? So here, the trend of the data, when the temperature increases, the number of hot drinks sold or bought, right, decreases. And then 1.2 says determine the equation of the least squares regression for the line. So we want to find the equation for the least squares regression line for the data we have, right? So it's very difficult to do it manually. So we're going to resort to using a calculator. So I have two calculators with me here. The one which you can see is on my phone, right? And then the other calculator which you cannot see is the normal one. So what you want to do when you want to find the least squares regression line, the first thing you press is mode, right? So I just pressed mode on the calculator, you can see right now, and then that menu pops up. But then on the normal Casio calculator, when you press mode, you're gonna have options with numbers on them, right? It's usually 1, 2, 3, and you want to click on the number that has stat, right? It's usually 2, but not always. So I'm clicking 2 on the calculator, on the normal calculator, and here on the phone I will click on the option that says stat, right? When you click that on the normal calculator, you're gonna have options from I think 1 to 8. You want to click on the option that has a plus bx, right? Because that's the general formula for the least squares regression line. On this scientific calculator that I have, it's option number 2, right? So I'm clicking number 2. But then on the calculator that you can see with your eyes here, you can see that a plus bx is option number 5, right? So I'm gonna click 5. After I click 5, the screens are the same. You have x and y, so you're supposed to put the values for the x and then the values from the y. So on the calculator that you can see, let me put the values. So we have 14, you press equals to 24, you press equals to 26, 18, 20, 28, 22, 17, 12 and 19. And then on the y values, we have 410, and then we have 258, 192, we have 324, not 321, 324, we have 328, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324, 192, 324 156, 156, 280, 384, and 230, right? And then we have 280. So we have entered all our numbers, right? Let me do the same thing real quick on the calculator. You can see. So after you've pressed that, after you've entered your data, you can press AC, right? So I'm gonna press AC here, and then we go back to the normal screen. I'm also pressing AC on the other calculator. So now what you want to press, Shift 1, right? So let me press Shift 1. When I press Shift 1, this menu pops up. So we have a few options here. I'm going to press option 3. It says regression calculate, right? And then on the normal calculator, we just have rig for regression, right? So on the normal calculator, you're going to press 5. So let me press regression calculate here. And then this calculator that I have will give you the value of A and the value of B, right? And then on the normal calculator, you're gonna have numbers from 1 to 5, right? 1 being A, and then 2 being B. But then that's not always the case. You just have to press the number for the letter you're looking for. So here on the screen, you can see that A is 488,3026, and then B is minus 10.2051. And then if I press number 1 on the normal calculator, I get an A value of 488.30.302561, right? They seem to be the same. And then after you've done that, you can press AC again, press Shift, press 1 again, press regression, and then press the number that has B, and then B is also minus 10.2051. Now we have A is equals to 488.3, right? And then we have B being equals to minus 10.21, right? So our equation will be Y is equals to minus 10.21x plus 488.3, and that's our equation for the least squares regression line for the data. And then 1.3 says that the owner observed that he had used 1 liter of milk for every 8 cups. So now let's say 8 cups is equals to 1 liter of milk, right? And then it goes on to say that if the temperature at 1 p.m. on the 11th day was expected to be 17 degrees Celsius, predict the number of 1 liter boxes of milk the owner should buy for the 11th day. So we are given the temperature on the day, right? With the temperature on the day, we can find the number of cups sold, right? The number of hot drinks. And from the number of hot drinks sold, we can then find the liters of milk needed. So now we're going to say Y is equals to minus 10.21. In place of X, we put in 17, right? Because our X is the temperature, plus 488.3. And that is giving me 314.73 cups sold, right? So now I can convert these cups to liters, because we know that 8 cups is 1 liter. So we're gonna say that the boxes of milk will be equals to the number of cups divided by 8. So we have 314.73 divided by 8, which is equals to 39.34, right? So yeah, it seems like we're going to need 40 boxes of milk, right? You cannot have a third of a box. So we're going to need 40 boxes of milk. And then 1.4 says, let's identify an outlier in the data. Let's go to our scatter plot. You can see clearly this point here that I've circled. That is very far away from the other points. And then apart from that, it sort of goes against common sense, right? Because the temperature is really low here, but the number of hot drinks that are sold are also very low, which doesn't make sense. Learners from various schools wrote an aptitude test in order to qualify for a bursary. Their marks as a percentage are represented in the ogive cumulative frequency graph below. And then we're given our ogive there with the cumulative frequency on the x, on the y, and the marks on the x as a percentage. 2.1.1 says how many learners wrote the test. So the number of learners that wrote the test is the total frequency, right? Or the cumulative frequency, so to say. So we can see from this ogive that the cumulative frequency is at between 180 and 70, right? You can see that this is where our graph ends here. And then if you extrapolate from there, you will end up at 175. So the number of learners who wrote the test is 175. So here, 2.1.1, we have 175. It's the cumulative frequency. 2.1.2 says, write down the modal class of the data. Now, the question is, what is the modal class of the data? We know the mode when we have ungrouped data, right? The mode is that number that appears the most, right? So the modal class when we have grouped data is the class that has the highest frequency, right? Because we assume that the class that has the highest frequency will have a lot of numbers that are the same, thus our mode will lie there. So we call it the modal class. So let's come to our ogive and look for a class with the highest frequency. So people between 0 and 10, I think it's only 4 people who got between 0 and 10, and then between 10 and 20, I think it's about 6 people. It's about 2 people actually, or something like that. But then you can see that we're basically looking at the distance between the two dots, right? So the interval, that is the largest distance between the two dots, then that will be our modal class. And then you can see fully well here that it seems like from 40 to 50, there's actually a big gap, right? Because if you want to find the students who got between 40% and 50, you're gonna come from this point, and then the cumulative frequency is 100 there. Come from this point, the cumulative frequency is 60. So you're gonna say 100 minus 60 is equals to 40, right? So people who got between 40 and 50 is 40 people, right? And then I think the next largest is 50 to 60, which is about 30 people. But then we're looking for the modal class, the class with the highest frequency, right? Clearly is 40 to 50, right? And then even if you write it like 40, and then you include 40 and exclude 50, it's still fine. So 40 to 50 is our modal class. Why are we saying it's our modal class? It has the highest frequency. How do we determine whether it has the highest frequency? We're subtracting the cumulative frequency from where it starts to the cumulative frequency where it ends. Let's go to 2.1.3. 2.1.3 says the minimum mark to qualify for a bursary is 75%. How many learners qualified for a bursary? So let's come to our x-axis here and look for 75%, right? So 75% will lie midway between 70 and 80. And then let's take the line up until we hit our ogive. So we are somewhere here, right? So everyone going there got the bursary, right? And then everyone going down didn't get the bursary. So let's find the number of learners who are up there who are going to get the bursary. We already know that the cumulative frequency is 175, right? And then let's subtract the number of people who didn't get the bursary so that we can know the number of people who actually got the bursary. At this point here, going down, no one got the bursary, right? So at approximately 160, so we have 175 minus 160. This will give you 15. So only 15 learners got 75% and above. So they are going to get the bursary, but everybody else didn't. So here we're gonna have how many learners qualified for the bursary? 15 learners qualified for the bursary. But you don't just write 15, you have to show that you are saying 175 minus 160 is equals to 15, and then you'll be fine. Let's move to 2.2. 2.2 says the table below shows the marks that 15 learners from one particular school obtained in an aptitude test. The marks are given as a percentage. 2.1 says calculate the mean obtained by these learners. We know fully well that the mean, or the average, is equals to the total sum of the data divided by the number of the data points. So what are we saying? We're saying 62 plus 58 plus all the numbers until the last number, right? 92 divided by the number of numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have that summation divided by 15. And then if you put that in your calculator, you're gonna get 74.8667, right? We're gonna round it off to two numbers, so 74.87. And then 2.2 says let's calculate the standard deviation of these learners' marks. So standard deviation, you can do it manually, right? But then it's only 1 mark, so there's no need to do that. You can just do it on your calculator. If you don't know how to do that with a calculator, you can let me know, and then I can do a dedicated video on how to do that. But then when I did it on my calculator, I'm getting a standard deviation of 16.12, right? And then 2.2.3 says let's calculate the number of these learners whose marks lie more than 1 standard deviation above the mean. 1 standard deviation above the mean. So let me just write it here. So we have the mean plus the standard deviation, right? So we want the marks that lie 1 standard deviation above the mean. So we have 74.87 plus 16.12, and this will give us a 90.99. So how many people got more than 90.99? 1 standard deviation above the mean, right? The question can also ask you to find people who got marks that are lower than 1 standard deviation below the mean. But anyway, let's answer the questions we are asked. So let's go to our data and look for those people. So we're looking for everything that is above 90.99. So basically 91 going up. Somebody got 100%, and then here somebody got 92. 90, they don't quite fall in there, and then another 92 here. So we have 1, 2, 3 people who got more than 1 standard deviation above the mean. So here your answer would be 3 learners. So 3 learners got marks that are 1 standard deviation above the mean. 2.3 says the final grade 11 marks as a percentage obtained by a group of learners was analyzed the 1 standard deviation interval about the mean, so below and above, right? Was calculated as, and we're given the points then. Calculate the standard deviation for the final grade 11 marks. So we want the standard deviation, right? We are given the mean minus the standard deviation, right? Which is equals to 82.7, one standard deviation below the mean, which is this number here. And then here we are given one standard deviation above the mean. So we are given x bar plus one standard deviation is equals to 94.1. But what we can do here is to find the mean first using these two equations, right? Here we have a plus, here we have a minus. So if we add these two equations, the standard deviation is going to disappear and we're going to be able to find x bar, right? After we find x bar or the mean, then we can just substitute it in one of these formulas and find our answer. We basically solving simultaneously here anyway. So let's say this is equation 1 and then this is equation 2. So we add in the two equations, right? We add in what's on the left together and what's on the right together. So we're gonna have x bar minus a standard deviation, right? Plus x bar plus standard deviation, right? This will be equals to 82.7 plus 94.1. So we add in whatever is on the right with whatever is on the left. The equations were balanced initially, so if we do that, the equations must still remain balanced. So x bar plus x bar, or the mean, that will be 2 x bar, and then minus standard deviation plus standard deviation, that will be 0, right? That will be equals to 82.7 plus 94.1, which is 176.8, right? So now we can just say the x bar is equals to, we divide in both sides by 2, we get in 88.4. Now you can substitute your mean in any of the two equations and get your standard deviation. So let's substitute it in equation 1. So we're gonna get the mean plus the standard deviation is equals to 94.1. So the standard deviation will be equals to 94.1 minus the mean, right? But lucky for us, we know what the mean is. So we have 94.1 minus 88.4, which is equals to 5.7. 3.1 says calculate the gradient of AB. So here's AB here, we have point A here and point B here, and then the line goes on until point C. But then we don't have coordinates for point A, so we cannot use m of AB is equals to y2 minus y1 divided by x2 minus x1. We also don't have coordinates of C. But then we have the angle of inclination of line ABC, right? So since we have the angle of inclination, we can use tan theta is equals to the gradient of AB, right? We are allowed to do this. From here, we can then say that tan of 45 degrees is equals to the gradient of AB. So the gradient of AB will be tan of 45 degrees is 1. So the gradient of AB is equals to 1. And that's how you do that question. And then 3.2 says show that the value of K is minus 6. K is the y coordinate of point A, right? And then since we have the gradient of AB, we can use the gradient formula to find the coordinate of K. So what we can say here for 3.2, we can say that the gradient of AB is equals to y2 minus y1 divided by x2 minus x1. Now it's on us to decide which point we take as point 2 and which point we take as point 1. So let's take B as point 2 and then A as point 1. You can do it the other way around, it still works. So the y coordinate of B is minus 2, so we're gonna have minus 2 minus the y coordinate of A, which is K, all divided by x2, the x coordinate of B, which is 8, minus the x coordinate of A, which is 4. And then we know that m of AB is 1. That is the gradient, right? So we have 1 is equals to minus 2 divided minus k divided by 8 minus 4. 8 minus 4, that is 4. We cross multiply, we get 4 is equals to minus 2 minus k. Take minus 2 to the other side, you get 6 is equals to minus k. Divide both sides by minus 1, so minus 6 is equals to k. And that is exactly what we are asked to show. So now the coordinates of A, we have 4 and minus 6, right? K is minus 6. And then let's move to 3.2. 3.2 says determine the equation of EA in the form y is equals to mx plus c. So let's look for EA. So here's EA here. EA is said to be parallel to FB, as we can see from the lines. And so fine, let's say 3.3, and then we know that y is equals to mx plus c. So we need m and c, right? But we can find the gradient of EA, right? The gradient of EA will be equals to the gradient of FB, since line EA is parallel to line FB. And then we have the equation for line FB, which is in the form y is equals to minus a half x plus 2. So now at this point, we can say that the gradient of EA is equals to minus a half. Why are we saying so? That is because EA is parallel to line FB. So now we're only left with C, and then we have point A. Don't forget that. So because we have point A, we can substitute it in our equation, and then we can find C, right? So if we sub A, which is made out of 4 and minus 6, we're gonna get minus 6 is equals to the gradient, which is a half, multiplied by x, which is 4 plus c, right? So we have minus 6 is equals to minus half of 4, that is minus 2 plus c. So we take in minus 2 to the other side, we get minus 4 is equals to c. So our equation becomes y is equals to minus a half x minus 4, right? Because we just figured out that c is minus 4, and we have our equation for EA. And then let's move to 3.4. 3.4 and then 3.4.1 says let's find the size of theta, right? So we're looking for the size of theta. So let's go back to our sketch again. Here's theta here. Angle PBA, it's our theta, right? So we'll need to find the size of that angle. What is theta equals to? Let's look at that. Theta is equals to, will be equals to this angle here plus this angle here, right? Because an exterior angle of a triangle is equals to the sum of two opposite interior. So now we can see that theta is equals to angle CPB plus angle PCB. So we have PCB, right? And then why are we saying that exterior angle of a triangle is equals to the sum of two opposite interior, right? So now we can go ahead and try find the size of CPB and the size of PCB, and then we would have theta. So let's look at CPB. So CPB is here. Let me change the color. So CPB is here, right? So how can we find CPB? We know that CPB plus this angle here, right, will be equals to 180 because they're on a straight line. So if we find this angle that I'm circling, then we're gonna be able to find CPB. But then how do we find that angle? Again, we can use the inclination of line FB, right? So again, we're saying that tan of theta is equals to the gradient of a line. We are interested in FB now, so we're gonna have tan of that angle being equals to minus a half, because that is the gradient of that line. So now that angle will be equals to tan arc minus a half, and that is equals to minus 29.5167. And you know, if you get a negative angle, you're supposed to add 180, and that will be equals to 150.4833. So this angle CPB, so CPB will be equals to 180 minus 150.4833, which will be equals to 29.5167, right? Now we can move to angle PCB. So let's look at PCB. So PCB, let me highlight it in green also. So PCB is here. This is PCB. PCB will be equals to this 45 degrees here, right? Vertically opposite angle. So we're saying that PCB is equals to 45 degrees. So now we can find theta. Theta is equals to the sum of the two, which is gonna be 45 degrees plus 29.5167, and that is all equals to 71.5167 degrees. Now let's move forward and find the length of BF. That's 3.4.2. So we want to find the length of BF, right? We know that the length will be given by x2 minus x1 squared plus y2 minus y1 squared, right? Again, in this case, we have to decide which point we take in as the second and which point we take in as the first. So we want the length of BF. Let me just erase some stuff here. So you'll realize that we don't have the coordinates of F. So let's find the coordinates of F first so that we can find the length of BF. So the coordinates of F, we know the x coordinate of F because it's a y-intercept. We can substitute we can substitute 0 into the equation and find the y coordinate, right? So we're gonna have y of F is equals to half of 0 plus 2. So half of 0 is 0 plus 2, that is just 2. So now we have deduced that the coordinates of F is 0 for the x and 2 for the y. So let's take point F as our second point and B as our first point, right? So here we're gonna have 0 minus x of B, which is 8 squared, plus y2, that will be 2, minus 2, that will be plus 4, right? Squared. And then if you put that in your calculator, you're gonna get 4 square root of 5. And then now we can move to 3.4.3. Let's look at 3.4.3. It's saying we must find the area of ABF. So let me just highlight ABF. So we have ABF. So we have our triangle ABF here, right? What is the formula for the area of a triangle? The area of a triangle is given by a half side 1 multiplied by side 2 and then sine of the angle. Which angle? The angle which the two sides sandwich, right? On a right angle triangle, the two sides that you will usually use will be sandwiching 90 degrees. So that's why it's usually written as just half base times height. But that is not always the case. You can choose to use the other sides as long as you will take sine of the angle the sides sandwich, right? So here for this question, I'm going to take side AB and side FB, right? So if I take those two sides, the angle they'll be sandwiching is theta, right? I already have theta, I already have FB. I just need to find AB and then I will have the area of my triangle. So now FB, we know fully well that FB is equals to 4 square root of 5. Now let's find AB, right? So AB will be equals to y2 minus y1 squared plus x2 minus x1. So let's take B as our second point, right? So y of B, that is minus 2 minus y of A, that will be minus 6. So we're just gonna have plus 6 here, squared plus x of B, that is 8 minus x of A, that is 4, squared, and then the length of AB is 4 square root of 2. So now we can say that the area of our triangle ABF will be equals to half side 1 4 square root of 5, right? 4 square root of 5 multiplied by the other side 4 square root of 2 sine of the angle, the sandwich, right? The sandwich theta, and we just deduce that the angle for theta is 71.5167. So we have sine of 71.5167. So when I do that, I get 22.8 units squared, right? Because it's an area. And then let's move forward and do 3.5. 3.5 says let G be a point in the fourth quadrant such that APBG is a parallelogram. Calculate the size of angle PAG. So we are interested in angle PAG if we have coordinate G on the fourth quadrant such that APBG is a parallelogram. So let's go see how we can possibly do that. So we have A, P, B, and we need G such that APBG is a parallelogram, right? So if G is somewhere here, then we get our parallelogram. So we are looking for PAG. So PAG is somewhere here, right? And then PAG is made up of BAG, which is this angle here, and PAC or PAB, which is the angle here, right? So if we break that angle into two, we can find it using BAG and PAC. So let's pay our attention to BAG first. So angle BAG. So we are looking at BAG, this angle here. This angle here, that's what we're interested for now. We're looking at BAG. So if you pay close attention, you will realize that BAG is supposed to be equals to angle theta, right? Why are we saying they're supposed to be equals to angle theta? PAGB is now a parallelogram. So those angles will be alternate angles. So now we can say PAG is equals to theta. Not only is it equals to theta, it will be equals to 71.5167 degrees, right? So we have found angle BAG. We can then look at angle PAC. So let's have PAC here, right? So let me just erase the information for angle BAG so that we can pay our attention to PAC. So PAC is this one that is left in green right now. So PAC will be equals to 45 degrees. Why am I saying so? Let's look at the triangle PAC, right? So let me just highlight triangle PAC. So here's triangle PAC here. In triangle PAC, angle CPA, this angle here, is 90 degrees, right? And then we already know that this angle here is 45 because it's vertically opposite to this angle here, that is 45. So we have 90 degrees, we have 45 degrees. We know that the angle should add up to 180. Then angle PAC should be equals to 45 degrees. And angle PAC is indeed 45 degrees. So now we can say that angle PAG is 45 degrees plus 71.5167. That will be equals to 116.5167. 4.1 says the equation of the circle centered at S. Yes, S on the diagram is x plus 8 squared plus y squared is equals to 4. 4.1.1 write down the coordinates of S, right? So 4.1.1. We know that the general formula for the equation of a circle is given as x minus a squared plus y minus b squared is equals to r squared. And then the point at the center of the circle will be given by a and b. So for our circle centered at S, the coordinates of S will be given by minus 8 and 0. It just says y squared, right? So that will just give us 0. And then this 8 will give us minus 8 based on this general formula we have, right? And then let's do 4.1.2. 4.1.2 says, show that the diameter of the circle centered at S is 4 units. So what is the diameter by definition? The diameter is equals to 2 multiplied by the radius, right? But what is the radius of our circle? We know that from the general formula, x minus a squared plus y minus b squared shall be equals to r squared, and we're given r squared. So with r squared we can find r and ultimately find the diameter, right? So r squared is equals to 4. Here it is right here, right? So we say in r will be equals to 2. We take square roots on both sides, right? So d, the diameter, will be equals to 2 multiplied by r, which is 2, and this is always equals to 4. So the diameter is equals to 4 units, and that's exactly what we are asked to show. Now let's move to 4.2. 4.2 says that if it is further given that SR is equals to 8 units, right? So SR is equals to 8 units. Problem solving 101. You have to write down the given information, right? And then R has coordinates minus 8 divided by 5 and 24 divided by 5. Yes, R here. And then 4.2.1 says, let's find the length of EM. So let's denote EM on our sketch. So here's EM. The radius of our big circle, right? So what information do we have? We know that SR is equals to 8 units. We also know that the radius of the small circle is 2 units, right? So we can say SE is equals to 2 units, right? SE is this distance here. We're saying it's 2 units. And then SR, this entire distance, is 8 units. So we can basically find the length of ER, right? And ER will be the diameter, which is 2 multiplied by the radius, and EM is our radius, right? What am I saying? I'm saying that SR, right, and the entire distance from S to R will be equals to SE, the radius of the small circle, plus ER, right? But then you can see that ER is the diameter, right? So it should be equals to 2 multiplied by the radius of the small circle, which is 2 multiplied by EM, what we are asked to find. So in place of SR, we can put 8 units. In place of SC, that's 2 units. And then in place of ER, that's 2 multiplied by EM. So you can see now that EM will be equals to 8 minus 2 divided by 2, right? So 8 minus 2, that is 6, and then 6 divided by 2, that is 3. So EM is 3 units, right? And now we can do 4.2.2. 4.2.2 says, let's find the gradient of tangent FE, right? FE is the tangent of both our small circle and our big circle, right? So we know fully well that the radius and the tangent are perpendicular to each other, right? The product of their gradients will give you -1. So if we find the gradient of ER or the gradient of SE, then we're going to be able to find the gradient of tangent FE, right? So let's find the gradient of SE since we have coordinates S, right? But wait a minute, we don't have the coordinates of E. So how are we still going to find the gradient of SE? The gradient of SE will also be equals to the gradient of SR because it is one straight line from S to E to M to R, right? So the gradient on that line is the same. So we can just use SR to find the gradient of SE. So that will be equals to y2 minus y1 divided by x2 minus x1 by definition. So let's take R as our second coordinate, right? We have the coordinates of R here. So y2 will be 24 divided by 5, and then y1 will be 0, right? Because S rests on the x-axis. So 0 divided by x2 minus 8 divided by 5 minus x1 of S, right? We know that that is supposed to be minus 8, so it will be basically plus 8, right? And then when you compute that, you get 3 divided by 4, right? But we know that m of SE multiplied by the gradient of the tangent should give you minus 1 by definition. So the gradient of the tangent will be equals to minus 1 divided by 3 divided by 4. So that will be equals to minus 1 multiplied by 4 divided by 3, that is minus 4 divided by 3. So the gradient of the tangent is minus 4 divided by 3. And now we can do 4.2.3. 4.2.3 says let's find the coordinates of M. The coordinates of M. So M is the center of the big cycle, right? What do we know up to this point? What do we know about up to this point? We know the radius of the big cycle is 3 units, right? And then we know the radius of the small cycle, it is 2 units. And then we know the coordinates of S, and then we know the coordinates of R. That's all we know, right? And we sort of know the X value, the Y value of our coordinate P, right? So we have to find the coordinates of M using this information that we have. So how can we possibly do that? M and P, they share the same X value, right? That is because if the x-axis touches the circle, then where it touches the circle will be the x value of the center of the circle. And then if it touches it along the y with the y-axis, then the y value will be the y of the circle, right? So M and P, they share the same x value. So if we can find the x value of P, we have the x value of M, right? Now we can say that SM squared is equals to SP squared plus MP squared. So what is SM? SM is SE plus EM, right? So that is 2 plus 3. So we have 5 squared being equals to SP. We don't have SP, but that's what we're looking for, right? So that we can find the x value of P, right? And then plus MP squared. MP squared is EM squared because they're all radiuses, right? From M to E, that's the radius. From M to P, that's the radius. So we have the radius is 3, so we have 3 squared, right? So SP squared is basically 5 squared minus 3 squared, right? So SP will be equal to 5 squared, that's 25. 3 squared is 9. So 25 minus 9 is 16. Square root of 16 is 4, right? So SP is equals to 4. But we know that the coordinates of S is minus 8 and 0, right? And then we have P, which is the x value, and 0 here, right? But we know that from S to P is 4 units, right? So what can be the possible value, x value of P here? It should be clear that the only possible value of P such that SP is equals to 4 should be minus 4, right? The descent from S to P will be 4 if the x value of P is 4. So now we have found the x value of our coordinate M. It's minus 4 and some y, which we do not know. Let's go back to our sketch again. If you pay more attention, you will realize that from P to M is 3 units, right? Because that is the radius, is 3 units. We already know fully well that the y value of P is 0, right? So if from P to M is 3 units, then the y coordinate of M should be 3. So the coordinates of M will be minus 4 and 3, right? And now we can move to 4.3.4. So we have 4.3.4, which says we should find the coordinates of E. So let's just erase some of this stuff. So here's E here, and we are interested in the coordinates of E. Now we have the coordinates of M and we have the coordinates of R. It should be obvious now that we're gonna use the midpoint theorem, right? We're gonna use M as a bait basically to find the coordinates of E, because we know that x of M, since it is the midpoint of ER, right? Why are we saying it's the midpoint of ER? Because from E to M is the same distance as M to R, and they're on the same straight line. So M is the midpoint of ER. So we can say x of M is x of E plus x of R divided by 2. But we know x of M fully well. That is minus 4, right? So we have minus 4 being x of E plus x of R. X of R is minus 8 divided by 5, right? And then everything divided by 2. You cross multiply, you get minus 8 is equals to x of E minus 8 divided by 5. So minus 8 plus 8 divided by 5 is equals to x of E. And then if you put that on your machine, you will get an x of E, which is equals to minus 32 divided by 5. So we have x of E being equals to minus 32 divided by 5. Now we can move our attention to y of E. We are applying the same idea. We say that y of M will be equals to y of E plus y of R divided by 2. Y of M, that is 3, right? We have already established that. Then y of E plus y of R, which is 24 divided by 5, everything divided by 2. And then now we can cross multiply. You get 6 is equals to y of E plus 24 divided by 5, right? So we have 6 minus 24 divided by 5 is equals to y of E, right? So what is y of E? Y of E will be, if you compute that, you get 6 divided by 5, which makes total sense, right? It's just slightly above 1, because 6 minus 24 divided by 5 should be 1 point something. So now we have E having coordinates minus 32 divided by 5 and 6 divided by 5. And there we go. Let's do 4.3. 4.3 says the circle centered at M, right? Circle centered at M. So we have M being minus 4 and 3. And then now on 4.3, they've given you the coordinates of M. Yeah. So it's shifted 1 unit to the left. So let's shift M 1 unit to the left, right? So it was at minus 4, which shifted 1 unit to the left, it will be at minus 5, right? And reflected on the x-axis to form a new circle centered at K. So it is reflected in the x-axis. So when we reflect in the x-axis, let's say we had a point A, right, of coordinates x and y. When you reflect on the x-axis, you get A x and then minus y. So when you reflect on the x-axis, you just have to put minus on the y value. So we have minus 3 here, right? Let's erase this. So there we go. We have our new center of the circle, right? The question is asking us, determine whether the point minus 8 and 0 lies inside or outside the circle centered at K. Show all calculations. So we've shifted the circle, right? We haven't changed the radius and everything. So the radius of our circle is still equals to 3, right? So when we calculate, let's name this point L. When we calculate the distance of ML, right? M is our new center, right? If it is greater than 3, then it makes sense to conclude that the point L of minus 8 and 0 lies outside of the circle, because the radius of our circle is 3. And then if it is less than 3, then that point will lie inside the circle. And then if it is exactly 3, then it lies on the circumference of the circle. So let's go ahead and compute ML. So we're saying that ML will be equals to, we know the distance formula, y2 minus y1 squared plus x2 minus x1 squared. So let's just go ahead and sub it in. So we're gonna get y2, let's take L as our second point, so that will be 0 minus 3, so that will be plus 3 squared, plus minus 8 minus 5, so that will be plus 5 squared, right? So we basically have 3 squared, which is 9, and then minus 8 plus 5, that is minus 3. So we have 9 plus 9. So we have the square root of 18 is the same as 3 multiplied by the square root of 2. So 3 multiplied by the square root of 2 is definitely greater than 3, right? So that point lies outside of the circle. So the point is outside the circle. 5.1.1 says, let's determine, without using a calculator, the value of the following. And then we're starting with tan of alpha. We know fully well that tan of an angle theta is equals to opposite divided by adjacent, right? The opposite is the y and the adjacent is the x. So tan of alpha will become the y of our coordinate of interest t here, right? Which is minus 2 divided by x, which is minus 1. So tan of alpha is basically just equals to 2. And then 5.1.2 says, let's find cos of theta. Maybe now you'd want to pause the video and try it out by yourself. Assuming that you did that, we know that cos of theta by definition is equals to the adjacent divided by the hypotenuse. So we have x divided by r, right? We've already established that we're using our point of interest t, right? So x will be equals to minus 1, and now let's find r. We know fully well from Pythagoras that x squared plus y squared is equals to r squared. So x is minus 1, we square it, and then y is minus 2, we square it, and that is all equals to r squared. So we basically take in the square root of 5 and say it is equals to r. So now cos of alpha will be equals to x, which is 1 minus 1 divided by r, which is square root of 5. And we can move to 5.1.3. So 5.1.3 says cos of alpha plus 45 in its simplest form. So we have cos of alpha plus 45 degrees in its simplest form. Let's not forget, we're supposed to do this without using a calculator, right? Now it will be a good time for you to pull out your trig identities, right? Because we know fully well from definition that cos of A plus B will be equals to cos A multiplied by cos of B minus sine of A multiplied by sine of B, right? From definition. And that's exactly how we're gonna do this question, because there's no way we can compute this as it is without using a calculator or changing it to this trig identity that we're introducing. So now we're gonna say cos of alpha plus 45 will be equals to cos of alpha multiplied by cos of 45 minus sine of alpha multiplied by sine of 45. So what is cos of alpha? We know fully well that that is minus 1 divided by the square root of 5. And then what is cos of 45? That is a special angle, right? That is 1 divided by square root of 2 minus sine of alpha, right? So what is sine of alpha? Again, let's go back to our definitions. We know that sine of theta is equals to opposite over hypotenuse. So that is y divided by r, right? So let's just plug that in. So we're going to have minus y, which is minus 2, and then r, which is square root of 5. And then sine of 45. Sine of 45 is a special angle, square root of 2 divided by 2. And then let's erase this and carry on with our equation. When I get to this point, I don't want to solve anything by head, right? I don't want to make any unnecessary mistake. I just put it in my calculator and get my answer, right? So I just did that, and I'm getting 1 divided by the square root of 10. And then 5.2 says that let's determine, without using a calculator, the value of the following expression. We have 2 sine of minus 20 degrees multiplied by sine of 160 degrees minus cos of 40 degrees. So this question, as soon as it says without using a calculator, I'm going to use a calculator first, and then I'm going to get the answer. After I get that answer, I will basically be proving that that answer is true, right? So when I put this on my calculator, I'm getting minus 1. So whatever I do, however I solve this question, I must get minus 1. If I don't get minus 1, there's something wrong I'm doing, right? So let's solve our equation. So this is equals to, so we have 2 sine of minus 20 degrees, right? What can you do to 2 multiplied by sine of minus 20 degrees? You can't do really much. So we're just gonna have 2 sine of minus 20 degrees. And then we have sine of 160 minus cos of 40 degrees, right? So we've already seen that we cannot do anything to sine of minus 20 degrees. And we need minus 1 some way, somehow. So if we could get minus 1 and minus 2 sine of minus 20, we're going to have our answer as minus 1, right? So we need to take everything else and push it towards 1 and sine of minus 20, right? That way, we are getting close to our answer of minus 1. So what can you do to sine of 160? We know fully well that sine of 160 is basically sine of 180 minus 20 degrees. And then minus cos of 40 degrees. Let's leave cos of 40 degrees like that, just for the moment. So 2 sine of minus 20, that's the same as minus 2 sine of 20 degrees. And then sine of 180 minus 20. So we are in the second quadrant, right? 180 minus 20 degrees. We know fully well that sine is positive on the second quadrant. So we can write that as sine of 20 degrees. And then now let's look at cos of 40 degrees. We know that cos of 2 theta is equals to 1 minus 2 sine of theta squared, right? Here we have 40 degrees, right? So cos of 2 multiplied by 20 degrees is equals to 1 minus 2 sine of 20 degrees squared. So in place of cos of 40 degrees, we can put 1 minus sine of 20 degrees squared, right? So let's go ahead and apply that idea. So here we're going to have minus 1 minus 2 sine of 20 degrees squared, right? And then that will all be equals to, so we have minus 2 sine 20 degrees multiplied by sine of 20 degrees. That will be minus 2 sine of 20 degrees squared, right? Minus, so let's solve that bracket. So we have minus multiplied by 1, that will be minus 1. And then minus multiplied by minus, that will be plus 2 sine of 20 degrees squared. So we have a minus 1 here. Here we have minus 2 sine of 20 degrees squared. Here we have plus 2 sine of 20 degrees squared. So it should be obvious now that our answer will be minus 1. The other two will cancel out. Now we can move to 5.3. 5.3 says consider, and we're given an expression, and then we are told to simplify that expression to a single trigonometric ratio. So let's write that expression down. We have 3 cos x multiplied by sine x, and then plus tan x multiplied by cos of 180 minus x squared, right? And then we're supposed to simplify it. So let's see what we can do. That will be equals to 3 cos x. What else can we do? There isn't much. So 3 cos of x, and then multiply by sine of x. Still not much you can do. Plus tan x. You can play around with tan x, right? We know fully well that tan x is equals to sine of x divided by cos of x. So let's put that in. So we have sine of x divided by cos of x. So we just want to see if that will take us anywhere. It's not all the time that when you have tan of x, you must do this. Sometimes you have sine of x divided by cos of x, and you change it to tan of x, right? We just trying our luck. And then multiply by cos of 180 minus x squared. 180 minus x, we on the second quadrant. And on the second quadrant, it's sine that is positive, not cos, right? So here we're going to have multiply by minus cos of x squared, right? It's only fair. So now we're going to have 3 cos of x multiplied by sine of x plus, right? And then now we can cancel cos of x with 1 cos of x here, right? So we're gonna be left with sine of x multiplied by cos of x, and then we're not dividing by anything because on the denominator we had cos of x and they cancel out, right? Now you might be asking yourself, where did the minus go to, right? It just disappeared. The minus didn't disappear, right? We have a square here, right? We're taking this to the power 2. So if you square anything, the minus has to go, right? Maybe the mistake I did here is that I put it outside. It should have remained here, right? But then that minus is gone because of the square. So now we have 3 cos x sin x plus sin x cos x. So that will basically just be equals to 4 cos x sine x. Look at it and tell me if it doesn't make sense. So now we have 4 cos x multiplied by sine of x. So we can apply another trig identity. In trigonometry, you have to know all the trig identities by heart. There's no other way. So we know fully well that sine of 2 theta is equals to 2 cos theta multiplied by sine of theta. If you multiply both sides by 2, so multiply this by 2, multiply this by 2, you get 2 sine of 2 theta is equals to 4 cos of theta multiplied by sine of theta. And that's exactly what we have here. 4 cos theta sine of theta, but we have x instead. So that will be equals to 2 sine of 2 theta, right? And we have simplified our expression into a single trigonometric ratio. We can move to 5.3.2. 5.3.2. 5.3.2 says write down the range of f of x is equals to the expression we basically had, right? So in place of f of x, we can just put 2 sine of 2 theta, right? And then now we have to go to the basics. We want the range of that function, right? We know that the range of sine theta is -1 and we go up to 1, right? And then if you multiply by 2 here, then the range will also go up by 2, right? Its highest point will then be 2 and then its lowest point will be -2. So here we're going to have a range. Y will be an element of some -2 to some 2 then. And then we can move to 5.4. Cos 3x divided by cos x is equals to 4 cos of 2x minus 3, right? So the rule of thumb when you solving trig identities is to pick the most complicated side, and then from the most complicated side you reduce it so that you get the simpler side, right? If you pick the side that is more simple, then it's very difficult to complicate it. So which side is complicated between the two sides? The left hand side is more complicated, right? We have a division there. It will be very difficult to produce a deviation from this expression, right? So let's take the left hand side and try make it look exactly the same as the right hand side. So what is our left hand side? We have our left hand side being equals to cos of 3x divided by cos x. But there's nothing special about cos of 3x. So there isn't so much manipulation we can do to cos of 3x. So instead, let's say cos of 2x plus x. And then we can divide all of that by cos of x. So now it should be clear that we can play around with cos of 2x plus x because we know that there's something special about that. We've already established what cos of a plus b is equals to. So we'll just go ahead and substitute it. But let me just write it down for the faint-hearted ones. So we're basically saying cos of a plus b, right, is equals to cos of a cos of b minus sine of a sine of b, right? It's on the back of the question paper when you're writing your exam, right? And then now we have that being equals to cos of 2x cos of x minus sine of 2x sine of x, and then we divide everything by cos of x. But we know for the world that there's something special about cos of 2x, right? And then there's also something special about sine of 2x. But then, let's not forget what we're trying to achieve. We have 4 cos square x. We have 4 cos of x squared minus 3, right? So let's break these terms, right? So we're going to have cos of 2x cos x divided by cos of x, and then minus sine of 2x sine of x divided by cos of x. Check it out and tell me if it doesn't make sense. So let's move forward. This will be equals to, so let's change cos of 2x to sine, because on the other hand we have sine, right? And then on our solution there is no sine, so that sine has to disappear somewhere somehow. So we know that cos of 2x will be equals to 1 minus sine of x squared, right? So we're gonna have 1 minus 2 sine of x squared multiplied by cos of x, everything divided by cos x. I'm sure you can see now that the division is falling away, right? We've gotten rid of it on this side. And then minus sine of 2x multiplied by sine x divided by cos x. Let's change sine of 2x to something that has cos, so that the denominators can also cancel out, right? And then we know fully well that sine of 2x is equals to 2 sine of x cos of x, and then we're still multiplying by sine of x, right? I'm just running out of space. Everything divided by cos of x. So cos of x cancel out with cos of x. So we are left with 1 minus 2 sine of x squared minus 2 sine of x multiplied by another sine of x, right? So that will be just sine of x squared, right? But our answer has cos of x, right? So let's change sine square x to cos of x. Now, how can we do that? We know that sine square x plus cos square x is equals to 1. So if we do that, we're gonna get 1 minus 2. So we have 1 minus cos of square x, right? Minus 2 multiplied by 1 minus cos of square x. And then if we simplify this, we should get what we are required to prove. So we're gonna have 1, and then we have minus 2 multiplied by 1, so that will be minus 2. Then minus 2 multiplied by cos of x squared, that will be plus 2 cos of x squared. And then the other bracket, we're gonna get minus 2 multiplied by 1, that will be minus 2. Then minus 2 multiplied by cos of x squared, that will be plus 2 cos of x squared. So if we add all that, so we have 1 minus 2 minus 2, so that will be minus 3, right? And then we have 2 cos of x squared plus 2 cos of x squared, that will be 4 cos of x squared. And we've proved exactly what we are required to prove. Let's move to 5.5. 5.5 says that let's determine the general solution of x in the following equation. Which equation do we have? We have 3 to the 2 tan x minus 3 to the tan x plus 1 being equals to 54. So when I see a question like this, I always look for the easy way out, right? Usually the easy way out is writing this 54 in terms of 3, right? If you can write that 54 in terms of 3, then you can just, find a way to drop the basis and then you just work with the exponents. But then it's so bad that we cannot do that, right? So we have to find another way of solving this. So let's say let 3 to the tan x be equals to k, right? Because 3 to the tan x is just a lot to process, but then k is just simple and straightforward. If we do that, we're gonna get, in place of 3 to the power 2 tan of x, right, we're just gonna get k squared, right? You can work that out and see if it makes sense. I think it does. And in place of minus 3 to the power tan of x plus 1, so let me break that down for you first, right? So 3 to the tan x plus 1 is the same as 3 to the tan x multiplied by 3, right? So here we're gonna have minus 3 multiplied by k, and then that is all equals to 54, right? So now we can take 54 to the left hand side. We're gonna get k squared minus 3k minus 54 is equals to 0, right? So now we can factorize this. So we have k is equals to 0. So the question I ask myself when I'm factorizing, which two numbers do I multiply and get this value here, minus 54, and then when I add them I get minus 3, right? Factors of 54 that I can do that with. Those factors are 9 and 6, right? Minus 9 and 6. So we have minus 9 and 6. So k will be equals to 9, or k is equals to minus 6. But what is k? We know fully well that k is 3 to the tan of x, and then we also have 3 to the tan of x on this side being equals to minus 6. This part falls away. It's wrong. It cannot be true. So we are only left dealing with that. So 3 to the tan of x will be equals to 3 squared. Now we drop the bases, right? So tan of x is equals to 2, right? So we can say x is equals to tan arc of 2, right? Tan arc of 2 is 63.43 degrees. But tan of x is not only equals to 2 on that range, is equals to 2 every cycle it completes at some point of time, right? So the right way of writing it, you say that x is equals to 63.43 plus some constant k multiplied by 180 degrees, right? And then 180 degrees is the range of tan, right? And then k should be a whole. In the diagram, the graphs of f of x and g of x are drawn for the interval x an element of minus 180 to 90 degrees. And then 6.1 says, for which values of x being an element of the given interval, will f of x multiplied by g of x be greater or equals to 0? So if we were dealing with exponential or cubic functions, I would suggest we solve this equation algebraically, right? And then see what our answer is. But then when we are dealing with trig functions, it's a bit complicated. We always have to resort to looking at the graph. So here, if f of x multiplied by g of x is greater than 0, then f of x needs to be positive and then g of x needs to be positive, right? Because if one between the two is negative, then the product will not be greater or equals to 0. Yeah, it's either they're both positive or one is positive and the other one is 0. So let's look for an interval where that is true. Clearly g of x is negative here, so this interval can be part of our answer, right? And then at minus 30 it's 0. So here this is where it starts getting interesting. And then f of x is positive on the interval we are given, right? So from minus 30 degrees to where the graph ends, the product of f of x and g of x is greater or equals to 0, right? So our answer here will be x is an element of minus 30 to 90 degrees. And then 6.1.2 says, let's look for values of x where g of x is equals to -1, right? Let me just erase this and let's look at g of x. So g of x, we're looking for values where it is equals to -1. This is -1 and this is -2. Here at -180 degrees, g of x seems to be at -1. And where else? Let's just draw a line and see. And at -60 degrees, it seems like it's at -1. What I'm doing here just gives us an idea of where the point we're looking at is, right? So now what you do, you substitute -180 into the equation of g of x and see if you get -1, and then you substitute -60 degrees on the equation of g of x and see if you get -1, and that is exactly what I'm getting. So here the values of x for which g of x is equals to -1 will be x is equals to -180 degrees, and when x is equals to -60 degrees, right? It's easy to see on the sketch, but you always have to put it in your calculator and see if it is true. So now let's look at 6.2. 6.2 says the y-axis is moved 90 degrees to the right. Determine the new equation of the graph originally called f in its simplest form. So our y-axis is moving from this point here to somewhere here. Moving the y-axis to the right just simply means that we're moving the graph to the left, right? So in a standard format, if you have a graph, h of x is equals to cos of x plus k plus q. If q is positive, you're gonna move your graph up, and then if q is negative, you're gonna move your graph down. And then for the value of k, if k is positive, you move your graph to the left, and then if k is negative, you move your graph to the right. So we're saying that we're moving the y-axis to the right, so we're moving x to the left along the x-axis, right? So based on this general formula, we have a k which is positive, right? So let's look at f of x. F of x is minus cos x plus 1. So let me just write that. So we have f of x, which is equals to minus cos x plus 1. And we want to move this graph 90 units to the left along the x-axis, right? So that will be f of x is equals to minus cos of x plus 90 degrees, right? We're moving it to the left, plus 90 degrees plus 1. Let me just erase this. And then now this is our new equation for the graph originally called f. We have moved it 90 degrees to the left because y is moving 90 degrees to the right. But then the question says in its simplest form, right? So this is not its simplest form, but then if you manage to get here, then you can get 1 mark of the 2. Yeah, now what's left is realizing that cos of x plus 90 degrees is equals to minus sine of x. So if you substitute that back in your equation, you get f of x is equals to minus multiplied by minus sine of x plus 1. So this will be equals to sine x plus 1. We have a 3D diagram here, and the first question, 7.1, is saying show that x axis here is equals to 5 divided by 2 cos theta, right? Let's look at triangle ADC, right, where x lies. On triangle ADC, the only thing we know is that this angle here is 90, and then this angle here is 2 theta, and then we have x there. We don't have any other information. But then if you look at triangle ADB, right, we have theta here, and then we have 5, right, a value here, and then here we have 90. So what you want to do in this kind of questions, you want to start with the triangle that has the most information and move towards to the triangle you're interested in. Clearly, triangle ADB has the most information compared to triangle ADC. So let's start from triangle ABD and move towards triangle ADC. How do we possibly do that? Triangle ABD and triangle ADC, they share line AD. So let's find line AD using triangle ABD, and then from line AD we then find a way to find the x. So here on triangle ABD, what we can say that sine of theta is equals to opposite divided by hypotenuse, right? So we're going to have sine of theta being equals to opposite is AD, and then the hypotenuse is 5, right? So if we cross multiply, we get AD is equals to 5 sine of theta. So now let's find a way to use AD to find x. If we had the length of DC, then we would just use Pythagoras, right? Because we have an angle of 90 here. But then unfortunately we don't have, so we're gonna use trig ratios. So we can say sine of 2 theta in triangle ADC, right, will be equals to opposite divided by hypotenuse. What is the opposite here? The opposite is AD divided by the hypotenuse, which is x. So again, if we cross multiply, we get AD is equals to x multiplied by sine 2 theta. So now we have two equations for AD. If we equate these two equations, we're going to be able to find x. So we can say now 5 sine of theta is equals to x sine of 2 theta. So we divide both sides by sine of 2 theta, right? We're going to get x is equals to 5 sine of theta divided by sine 2 theta. This is not exactly what we're looking for, but then if we use the trig identity, sine of 2 theta is equals to sine theta multiplied by cos theta, then we can possibly get there. So now we're going to get x is equals to 5 of sine theta divided by 2 sine theta and cos of theta. So sine theta and sine theta cancel out, and we are only left with x is equals to 5 divided by 2 cos of theta. And that's how you do 7.1. And then 7.2 says calculate the length of BC if it is given that angle BAC is 112 degrees and theta is equals to 30 degrees. So let's look at BAC, right? So we have an angle here, BAC, which is said to be 112 degrees. So on triangle ABC, we have angle BAC, we have the length of AC, right, which is x, and we just calculated it. And then we have AB, which is 5. We know from definition that the cosine law says that a squared is equals to b squared plus c squared minus 2bc cos of a, right? So a is the side you're interested in, b and c are the other two sides of the triangle, and a is the angle which is opposite to the side you're looking for. So if we're looking for BC, A here will be 112 degrees, right? So let's apply the same idea. So we can say that BC squared, right, will be equals to AB squared, will be equals to AB squared plus AC squared minus 2 multiplied by AB multiplied by AC cos of BAC. So this will be equals to, what is AB? AB is 5, right? So we have 5 squared plus AC squared. AC is x, right? And we know what x is equals to. So here we're going to have 5 divided by 2 cos of theta. But we are given theta, it is said to be 30 degrees. So we can substitute 30 degrees here. And then minus 2AB, we're saying that AB is 5. And then AC AC is 5 divided by 2 cos of 30 degrees. And then cos of BAC, which is 112 degrees, right? This is BC squared. And then you will find that BC squared is equals to 44.147. And then if you take square roots on both sides, you get BC is equals to 6.64 units. When it comes to cycle geometry, getting the keywords right from the statement is the most important thing, because with the keywords, you are then able to answer all the questions. If you're wondering why I'm starting with 8.2, 8.1 was saying let's prove the turn chord theorem, and we've already done that. I will leave the link in the description. In the diagram below, PWRS is a cyclic quadrilateral. So cyclic quadrilateral, I'm writing that down. So we have cyclic quad, and then the circle is centered at O. PSW is an equilateral triangle. So I have triangle PSW, which is equilateral. So when the triangle is equilateral, all the angles are equal. The only way all the angles can be equal is if all the angles are equals to 60 degrees. TW is a tangent to the circle, so we have tangent. And then we have radii OR, right? Radius OR, so let's say radii. And then OW are drawn, and then we are told that W1 is equals to 25 degrees. So all the questions that we are going to answer, we are going to stick to these keywords, except from basic things like angles on a straight line and so on. So 8.2.1, A says determine given reasons the size of S1. So we are interested on S1. Yes, S1 here. So how can we use cyclic quad to determine S1? S1 is not a complete angle, right? So I don't see how we can immediately jump to S1. The next keyword talks about triangle PSW being equilateral. S1 is not in that triangle, so I don't see how we can use that. And then the third point talks about the tangent. We have tangent TW, right? And this is how we are going to determine S1. Look at W5. W5 is between TW and RW. And then at the same time, RW subtends S1. So S1 will be equals to W5. It will be equals to 25 degrees. And why are we saying so? Turn chord theorem. And then let's move to B. B says let's find O1. Again, we're not thinking about anything else other than the 4 keywords we have. Cyclic quad, there's no immediate connection between O1 and the cyclic quad. Angle PSW, O1 is not an angle on PSW, right? So it cannot help us with anything. And then tangent, O1 is at the center of a circle. There's no immediate way that is connected to a tangent, right? Because usually when we're talking about tangent, we're talking about the turn chord theorem. And now the only option we're left with is radii, right? Let's look at how radii can help us. Obviously, OR and OW are equal to each other. So angle R2 will be equals to angle W3 plus W4, right? We're saying that this angle here is equals to this angle here. So now we can say that O1 is equals to 180 minus 2R2, right? Because we're gonna minus R2 and we're gonna minus W3 plus W4. But we know that W3 and W4 is equals to R2. So minus 2R2. So if we can find a way to find R2 or W3 and W4, then we can find angle O1, right? OW is a radius, right? And it touches the tangent. Where it touches the tangent forms an angle of 90, right? We know that for sure. So now we can say that W3 plus W4 plus W5 is equals to 90 degrees. I'm talking about this angle here, right? But we know what W4 is. We know what W5 is. W5 is 25 degrees, right? So we're going to have W3 plus W4 being equals to 90 degrees minus 25 degrees. And that will be equals to 65 degrees. So now in place of R2, we can put 65 degrees. So we're going to have O1 being equals to 180 minus 2 multiplied by 65, which will be 130. So O1 is equals to 50 degrees. We just stick into the keywords and nothing else. So A has 2 marks, B has 2 marks, and then C has 5 marks. And then now let's do 8.2.2. 8.2.2 says, let's prove that SP is parallel to TW. So we're proving that SP is parallel to TW. Obviously, we don't have coordinates here, so there's no way we're going to be calculating the gradient. We have to do that using angles some way, somehow. So if these two lines are parallel, then this angle here, W1, should be equals to this angle P here. But then at the same time, W1 should be equals to S2. Why are we saying that? To our keyword again, tangent. We're using the tan chord theorem, right? We're sticking to the keyword. So now we can say that W1 is equals to S2. We already said that S2 will be equals to 60 degrees, right? Why are we saying S2 is equals to 60 degrees? Because triangle PSW is an equilateral. So W1 is equals to S2, but S2 is equals to SPW. There are angles on an equilateral triangle, and all those angles will be equals to 60 degrees. And we're done with 8.2.2. We can give a reason and say that they are alternate angles. And then let's move to 8.3. 8.3 says, in the diagram below, a circle centered at O is drawn. H, J, G, and L are points on the circle. Triangle HGL is drawn. HOG bisects GL at M. So we have 90, and then we're given the values of the lengths. And then 8.3.1, if MG is equals to 6 units, so let's denote MG, right? So we are told here that MG is 6 units and OM is X units. So we have X here for OM. Write HM in terms of X. So let's look at HM. So H starts here and then it goes down to M, right? So we want the length of HM in terms of X. HM is basically equals to 2 radius minus mg, right? Because if we're looking for hg instead, then it will just be 2 radius, right? But then the only difference between hm and hg is that hm stops here at m, and then we have that 6 going forward. So hm is basically 2 radius minus mg. But what is the radius? We have OH as the radius, right? But then OG is also a radius. So let's write the radius in terms of OG. So if we write the radius in terms of OG, it will be X plus 6, right? From here at O to M and from M to G, it will be X plus 6. So if we substitute that in place of the radius, we're gonna get 2x plus 6 and then minus mg, which is 6, right? So that will be equals to 2x plus 2 multiplied by 6, 12 minus 6. So hm will be equals to 2x plus 6 units, right? And then now we can move to 8.3.2. Calculate, given reasons, the length of the radius of the circle. So we already know that the radius of the circle is equals to x plus 6, right? So on this question, we can use triangle OG OJM, right? Let me just clear something so that we can make it more clear. We are looking at triangle OJM, right? We have the radius of triangle OJM, which is equals to the radius of the circle. So that will be x plus 6, and then we have 12 as the adjacent, and then x as the opposite, right? So we know fully well that on a right angle triangle, don't forget the angle here is 90, the radius squared will be equals to x squared plus y squared, right? The other two sides. So what is the radius here? The radius is x plus 6. So we square it, and it will be equals to the adjacent, which is 12. So we're going to have 12 squared plus the opposite, which is x. So we're going to have x squared. So what is x plus 6 squared? X multiplied by x is x squared. X multiplied by 6 is 6x. You multiply that by 2, you get plus 12x. And then 6 multiplied by 6, that is 36. And that will be equals to 12 squared, 144. Plus x squared, right? So look at this. We have x squared here, we have x squared here. So they're going to fall off, right? We're going to be left with 12x plus 36 is equals to 144. So 12x is equals to 144 minus 36. So we have 12x being equals to 108. You divide both sides by 12, you get x is equals to 9, right? But then we're not looking for x, we're looking for r, right? And we know fully well that r is equals to x plus 6. So that will be 9 plus 6, 15. When we do Euclidean geometry, we are guided by the keywords and nothing else. So for question 9, it's saying that in the diagram below, P, Q, R, and S are points on a circle. Clearly, and then PS, PQ, PR are produced to V, T, and W respectively. VT is parallel to SQ, right? And then we know that there's a lot we can deduce from lines being parallel. So that can count as a keyword. So VT is parallel to SQ. And then it goes on to say that SR is parallel to VW. So our second keyword, SR, is parallel to VW. So we must be able to answer all our questions using these two keywords, except from the basics. Things like angles on a straight line, angles on a triangle 80 to 180, angles subtended by the same chord. But these are only the keywords we're gonna need to answer this question. So 9.1 says, prove given reasons that TQ divided by QP is equals to WR divided by RP. So where's TQ? So we have TQ here divided by QP being equals to WR divided by RP. Okay, so let's look at the first keyword. The first keyword says VT is parallel to SQ, right? So let's look at the VT. VT is this line here, and it's said to be parallel to SQ. SQ is this line here. If those two lines are parallel, then the sides PT and PV will be divided proportionally, right? In triangle PTV, if QS is parallel to VT, then the two sides will be divided proportionally. What are we saying? We're saying that TQ divided by QP will be equals to VS divided by SP. We can only say that if we have two lines that are parallel on the triangle, right? They will divide the two sides proportionally. So that's all we have deduced for now. Let's move on and go to our second keyword. Our second keyword says that SR is parallel to VW, right? So let's erase these parallel lines for QS and VT, and let's pay our attention to SR and VW. So where's SR? SR is this line here, and then we have VW, which is this line here, right? So if those two lines are parallel, then in triangle PVW, right? PVW, the two sides will be divided proportionally. WR divided by RP will be equals to VS divided by SP. But then how does that help us answer our question? I want you to realize something here. We're saying that TQ divided by QP is equals to VS divided by SP, and WR divided by RP is equals to VS divided by SP. We know fully well that if A is equals to C and B is also equals to C, then A and B are equals to each other because they are all equals to C. So if we apply the same idea here, we're now saying that TQ divided by QP is equals to WR divided by RP. Why are we saying that? They are all equals to VS divided by SP, and we have proved what we are required to prove. Let's move to 9.2. 9.2 says, let's prove given reasons why TPVW is a cyclic quadrilateral, right? So let's look at TPVW. So we have T here, we have P here, and then we have V, and W is here. And then it is said that we must prove that it's a cyclic quadrilateral, right? So it's a cyclic quadrilateral if those four corners can lie on the circumference of a circle, right? So we must be able to draw a circle around TPVW, and then the 4 points lying on the circle. So let's just construct a circle. It's not really clean, but yeah, this is what we essentially saying when we're saying that TPVW is a cyclic quadrilateral. We should be able to construct a circle around TPVW, and all the points lie on the circumference. So I want you to realize something here. If these points lie on the circumference, then angle T should be equals to, don't forget we have W here. Angle T should be equals to angle W, because they are getting subtended by the same chord PV, right? That's if indeed it's a cyclic quadrilateral. So if we can prove that, angle T is equals to angle W, then we have proved that TPVW is a cyclic quadrilateral. Because if indeed it's a cyclic quadrilateral, then T and V should be equals to each other, because they will be subtended by the same chord PV. So let's find a way to connect T and V using the circle we already have and our parallel lines. Let's go back to the keywords again, because we agreed that for this question, we're only gonna stick with the keywords, right? All questions on Euclidean geometry, you stick to the keywords and nothing else. So the first keyword says VT is parallel SQ. So VT with parallel SQ. If VT is parallel SQ, then Q1, this angle Q1 here, should be equals to angle T. Q1 and T are corresponding angles. So let's write that down for the sake of clarity. So we say in Q1 is equals to T, because they are corresponding angles, right? And then let's go back to our keywords. So we've used the first one, we are only left with the second one, right? SR and VW. If SR, let me make SR clear. So if SR is parallel VW, then angle R1 should be equals to angle W, right? They are also corresponding angles. So let's write that down. So we're saying R1 is equals to W, but we need the T to be equals to W. So we have to find a way to relate Q1 and R1, right? If we can prove that Q1 and R1 are equals to each other, then T is equals to W. So how can Q1 be equal to R1? Let's look at our diagram. So we have Q1 here, and we say that it must be equals to R1, right? And then indeed it is, because PS subtends Q1 and it subtends R1, right? So now we can say that Q1 is equals to R1 because they are in the same segment, right? So T is equals to Q1, but Q1 is equals to R1 and R1 is equals to W. So T and W are equals to each other because they are all equals to Q1 and R1. So by saying that, we have essentially proved that TPVW, it's a cyclic quadrilateral. When we did question 8 and 9, we realized that you can answer all the questions using only the keywords in the statement. So we're gonna try and apply the same idea to this question. So it says that in the diagram below, BCD are points on a circle such that BC is equals to CD, EC and ED are tangents, right? So tangent is a keyword because we have a theorem that talks about tangent, the tan chord theorem, right? So I'm going to write that down. I have tangent, and then it goes on to say that BC produce meet tangent DE produce at F, angle B is equals to X. So it seems like the only keyword we have is tangent, right? And this question is out of 17 marks. So we should get all of these 17 marks based on the keyword tangent and nothing else, right? So we're just combining the keyword tangent and just a few basics, the sum of angles on a triangle, angles on a straight line, and so on. But then in the grand scheme of things, we're answering all the questions using the word tangent. So the first one, 10.1, says, so we have 10.1 says prove given reasons that E1 is equals to 180 minus 2x. So 10.1.1, we are asked to prove that E1 is equals to 180 minus 2x. So let's look at E1 on our graph. So here's E1 here, right? And then E1 is on triangle ECD, right? On triangle ECD, we have angle C2 and angle D1. There's nothing else we can do. We have to look at the tangent and consequently the tan chord theorem, right? Because that's the only keyword we have. If you look at C2, you will realize that it is equals to angle B, right? Because of the tan chord theorem. Angle C2 is between tangent CE and chord CD, and then chord CD subtends angle X, right? So C2 is equals to X. Why are we saying so? The tan chord theorem, right? We don't have much of a choice. We only have tangent. So all the questions we have to answer them based on the tan chord theorem. And then at the same time, D1 is also equals to B, right? Because D1 is between tangent DE and chord CD. And as we have said, chord CD subtends angle B, right? Which is X. So now we can say that D1 is also equals to X. So now you realize that E1 plus C2 plus D1 should be equals to 180 degrees, the sum of angles on a triangle. So now we can find E1 by saying that it will be equals to 180 minus C2 minus D1, which are all equals to X. So it's 180 minus 2X, and then that's how you find E1. Now we can move to 10.1.2. 10.1.2, we still have one keyword, right? proving that angle E1 is equals to 180 minus 2x doesn't give us any other keyword. So we're supposed to answer 10.1.2 using the tangent again, because that's the only keyword we have. So we're supposed to prove that triangle ECD is similar to triangle CBD. So let's look at these triangles on our sketch. So we want ECD. So here's ECD here. And then we're supposed to prove that it is similar to triangle CBD. So we have C going to B and back at D. So when you're proving similarity, you need two angles to be equal to each other. As soon as two angles are equal to each other, the other two remaining angles will be equal to each other, and you will have proved that the two triangles are similar, right? So the way the examiners name their triangles, right? They name them with respect to the angles that are equal. So angle E in triangle ECD should be equals to angle C in triangle CBD, and then angle C on triangle ECD should be equals to angle B, because it's the second letter of how they name the triangle, right? And then angle D on ECD should be equals to angle D on CBD, right? So let's start with angle E on triangle ECD. So angle E on triangle ECD is here, right? It's E1. We know that it's 180 minus x. So we're saying that angle CE should be equals to angle C on triangle CBD. So it should be equals to this angle, and indeed they're equal, because I want you to realize something. In triangle CBD, right, C3 will be equals to 180 minus 2x. Why am I saying 180 minus 2x? Because B, we've already established that it is x, right? But this angle D2 here will also be x, because line CB is equals to line CD, right? So C3 will be 180 minus x minus x. So we have proved that C3 is equals to E1. Now we can move to the following angles. So we're saying that angle C in triangle ECD should be equals to angle B in triangle CBD, right? So angle C in triangle ECD, it's C2, right? And then we have already proved that it's equals to angle B because of the tan chord theorem. So now we can see that C2 is equals to angle B is equals to x. Why are we saying so? Tan chord theorem, right? Now we've proved that two angles are equal in these two triangles. So the third angle, without proving it, already we know that it is equal, because those angles should all add up to 180, right? So now we are basically done. We can conclude that indeed ECD is similar to triangle CBD. Pay attention to the letters next time you solve this kind of problems. It always works. And then let's move to 10.2. 10.2 is saying to us, we have 10.1, which says prove given reasons. So we have 10.2.1 is saying that CD squared is equals to CE multiplied by BD, right? Let me just clear these sketches up so that we can have a bit of more clarity. So we want CD squared. So we want CD squared to be equals to CE multiplied by what? Multiplied by BD. Multiplied by BD. So if you pay attention here, these sides that we're interested in are sides on our similar triangles, right? So we can use the fact that those triangles are similar to find 10.2.1. So we moved from the word tangent, and now we have figured out that we have two triangles that are similar, right? So we can use similarities as one of our keyword, right? But then we're not just taking it out of thin air. We're using it because we have proved that indeed they are similar. So for 10.2.1, we're going to use similarity, which we proved through the tan chord theorem. our main keyword. From what we are required to prove, you can see that we some way somehow need CD, right? And then apart from CD, we need CE and BD, right? So our proportionality should involve those sides, right? From what we are required to prove. So let's start with CD. So we can say that CD divided by something. So CD is the smallest side of triangle CBD, right? So let's say CD divided by BD, right? The biggest side of triangle CBD. And then let's do the same thing on triangle CED. So the smallest side on triangle CED is CE, right? So we're gonna say CE divided by the biggest side on that triangle, which is again CD, right? And then that should be true if the triangles are similar. So now from here, we can cross multiply. So we can say that CD multiplied by CD will be equals to CE multiplied by BD, right? And you will see that CD squared will be equals to CE multiplied by BD. If you take a ratio of the smallest side to the biggest side on one triangle, it should be equals to the ratio of the smallest and biggest on the other triangle, right? It doesn't have to be smallest and biggest in that order. You can do it in any other way. But then as long as you do the same thing on the two triangles, the ratio of the two sides must be equal to each other. And that's how you would do 10.2.1. So the way you justify what I just wrote here is by stating that triangle ECD is similar to triangle CBD, right? And then let's move to 10.2.2. 10.2.2, we are required to prove that CF squared divided by EF squared is equals to BD divided by DE, right? Which is a bit complicated, but it's fine. So CF is not in any of those triangles, so we cannot use those triangles to prove 10.2.2. We have to resort to something else, right? But take a look at this. If line CE is parallel to line BD, then it will be quite easy to say that CF divided by EF will be equals to something, right? But then, are they parallel? Let's look at that. We know fully well that if they're parallel, then we can construct something like this. Not really construct because it's already there. But then this angle C2 should be equals to this angle D2. That's if the two sides are parallel. And then guess what? That's true because C2 is equals to X, and then D2 is also equals to X. So C2 is consequently equals to D2. So by saying that, we've basically proved that CE is parallel to BD, right? Because we have those alternate angles being equals to each other, right? And then now, since we have proved that, we can see that BC divided by CF is equals to DE divided by EF, right? We can play around with things like this once we have proved that CE is parallel to BD, right? We can play around with those ideas, but that's not where we're going. That's not what the question is asking us. We have to look at CF and EF, right? We are guided by the question. So let's say CF divided by EF and see where that can take us. So if we say CF, right? CF is this line divided by EF, then we can say CB divided by DE. The two lines CE and BD are parallel, so we can get away with that. So let's say that. So saying that CF divided by EF will be equals to BC divided by ED. And why are we saying that? CE is parallel to BD. We can get away with that. So now we have CF squared and EF squared. We know fully well from grade 3 that if A is equals to B, then A squared should be equals to B squared, right? No questions asked. The other way around is not necessarily true. Then if A is equals to B, then A squared should be equals to B squared. So we can say CF squared divided by EF squared is equals to BC squared divided by ED squared, right? And then that's it. We're still not quite there. What else are we missing? Okay, 10.2.1. Now we know from our sketch that BC is equals to CD, right? So if BC is equals to CD, then BC squared should be equals to CD squared. And we know exactly what CD squared is equals to from 10.2.1, right? So in place of CD squared, we're gonna put CE multiplied by BD. Here it is. So now we can say that CF squared is equals to EF squared. And then in place of BC squared, we put in CE multiplied by ED. So here we can have CE multiplied by BD, right? Divided by DE. But we're not, divided by B or DE squared, right? But we're not quite there yet. We need DE on the numerator, right? So that we can lose that square on the denominator. So which one between CE and BD is equals to DE? Let's look at our sketch. So let me remove a few things for clarity. So we know that this angle here is X, this angle here is X, and then here we have X and here we have X. So if we have X here and we have X here, then CE should be equals to DE, right? So in place of CE, we're gonna put DE. So we have CF squared being equals to EF squared, which is equals to, in place of CE, we put in DE multiplied by BD divided by DE squared. So DE and DE, we're left with CF squared divided by EF squared being equals to BD divided by DE.